The need for alternative energy is inevitable as the non-renewable energy like fossil fuel is finite, which means that one day it will run out. And one of the alternative energy is biofuel or bioethanol, which is made from different plant materials. With biofuel or bioethanol, we can reduce the amount of greenhouse gases that emit from different sources, like from our cars. However, the industrial process for generating bioethanol is hindered by high costs as the variety of pretreatment is necessary. So, to overcome this problem, an integrated biorefinery strategies need to be designed that provides high ethanol recovery and value-added product like cellulose nanocrystals. Hello everyone, my name is Dagem Haddis and I'm a PhD student at University of Alberta. Today I'm going to share you my research on production of fermentable sugar and cellulose nanocrystals. My research has two steps. The first step is producing this fermentable sugar, and this fermentable sugar is used to make a bioethanol. And the second step is producing a novel nanostructured material called cellulose nanocrystal. I bet you are wondering what a cellulose nanocrystal are and what they are used for, right? So you need to wait and find out, okay? But before that, let me tell you this. In recent decades, human activities have increased, and with that, energy demand also increased. As you can see in this image, the demand for both renewable energy and non-renewable energy is continuing to increase. But unfortunately, as I said above, non-renewable energy sources have negative effect on the environment by releasing greenhouse gases and causing climate change, as well as other chemicals like sulfur that causes acid rain and affect the soil fertility as well as the aquatic environment, and many other impacts. In order to overcome such problems and still provide enough energy for everything we want, renewable energy plays a major role, which is where bioethanol comes in. So, what's a bioethanol? Bioethanol is a renewable fuel made from plant matter and produced by a sugar fermentation process. A fermentation process is a process of converting carbohydrate to alcohol or organic acid using a microorganism. So to produce bioethanol, there are three basic steps. The first step is the pretreatment step, where the cellulose opened up to help it turn into glucose. And the second step is the enzyme hydrolysis, where the cellulose is turned into glucose or sugar by the help of enzymes. An enzyme is a biological catalyst which is used to facilitate or help a biochemical reaction. And the third step and the backbone step is the fermentation step, where the glucose is turned into ethanol by the help of the yeast. I think you know what the yeast is, right? The yeast is the microorganism and that we used to make bread, right? But however, because of the many steps and high pretreatment costs, producing this bioethanol at industrial level doesn't make sense from the financial point of view. So to overcome this many problems, we can produce multiple products, which is what I'm looking at. As you can see, during the second steps, enzyme hydrolysis, two products are made. One is the hydrolysate, which is the fermentable sugar that turned into bioethanol, and the second is the solid fraction. So this solid fraction can be turned into our cellulose nanocrystal. Remember those? Cellulose nanocrystal are a nanostructured biomaterial. This means it is made of a very, very small cellulose crystal that are extracted from wood, algae, or bacteria. And these cellulose nanocrystals have a promising application in biomedical application like in tissue engineering, drug delivery, and it also used to make food packaging material, and it used to make for cosmetic products in order to increase the viscosity, makes it harder to pull, and strength of the material. Now, I want to welcome you to our lab, and this is my workplace. And today, I'm going to show you how to make a fermentable sugar. And this fermentable sugar is used to produce bioethanol and a novel nanostructured material called cellulose nanocrystal. I hope you know what's the cellulose nanocrystal, right? So, let's make it. So, to make cellulose nanocrystal and fermentable sugar, we need the following materials and chemicals. The popular wood chips that we received have already been treated with a steam called steam explosion pretreatment and purified, which remove the parts we don't want, like lignin, and opens up the structure in the wood so that the cellulose can be accessed by the enzymes. Now we are going to start the second step, enzymatic hydrolysis, where we turn the cellulose into glucose. Using the scale, measure out 6 grams of pre-treated popular wood chips. Then, using a graduated cylinder, add 75 ml of 0.05 molar of sodium citrate buffer, and wood chips into 500 ml flask and put a rubber stopper on flask. Then cover the stopper with a paraffin and aluminum foil to avoid loss of glucose by evaporation during enzyme hydrolysis. Put the flask in the water bath. And using a thermometer, monitor the temperature of the water and bring the flask to 50 degrees Celsius. The flask should be kept at this temperature for 1 hour. And then remove the rubber stopper and add cellulase enzyme. The enzyme breaks down the cellulose and turn into glucose. And this should be done using 100 to 1000 microliter pipette. So the flasks should be kept at a constant 50 degrees Celsius in the water bath because the enzyme needs a warm environment to turn the cellulose into glucose. So after 24 hours, we separate the fermentable sugar and the solid fraction. So the fermentable sugar is going to a glucose analysis, which means that it's going to determine the amount of glucose is produced during the enzyme hydrolysis. And the solid fraction is dried and going to acid hydrolysis for the production of cellulose nanocrystal. For the acid hydrolysis of cellulose nanocrystal, it is where the solid fraction is converted into a very, very small cellulose. We prepare 64% by weight sulfuric acid using a graduate cylinder, add 8% solid consistency of sulfuric acid to 250 ml flask. Then flask should be kept at a constant 45 degrees Celsius in the water bath. We use a thermometer to monitor the temperature. Then the dry solid fraction is placed into 250 ml flask and the acid hydrolysis happens for 2 hours. After acid hydrolysis, we separate the acid and the cellulose nanocrystal and purify to get pure cellulose nanocrystal. So to purify, first what we do is we neutralize the diluted acid suspension using sodium hydroxide to bring the pH into 7. And after that, we are going to dialyze against water in order to remove the salt that are produced during neutralization process. And then we centrifuge 2 times at 8000 G for 10 minutes. And then after that, we use freeze dryer in order to remove the moisture or the water from the suspensions, and we get a dried cellulose nanocrystal. Okay, to wrap up my work, now we have the cellulose nanocrystals, which can be used for many different purposes, and we have the sugar that will be used to create bioethanol. So if we can't find ways to make bioethanol production, it makes more sense financially, then we can play an important role in making renewable alternative energy. Thank you very much for watching my video. I hope you liked the video and you get information. And finally, I would like to thank my supervisor, Dr. David Bressler, for his guidance, advice, encouragement throughout the research work and useful suggestions and comments. And also, I would like to express my sincere appreciation to Dr. Che, Dr. Asomania, and Jungi for supporting me to carry out this research. And finally, I would like to thank all my lab mates and the funding agencies, the Future Energy Systems, Natural Science and Engineering Research Council of Canada, Alberta Pacific Forest Industry, and Innotech Alberta. Without the support of the funding agencies and my professor, this work would not have been possible. So, once again, thank you very much for your support.
Thank you so much for watching Future Energy Systems video. Make sure to subscribe so you don't miss any of our exciting content. Check out the links below to our website and learning page where you can find activities, learning extension, and more. You can also sign up on the website for notifications for future videos and interactive opportunities. There's so much to learn as we explore our energy future.